In this video, I will cover maps in Java. Let's start. Map is a data structure that supports the key-value pair mapping for the data. This data structure is useful when we work on the basis of the key. When we just want to perform operations to the elements of the map, basis of the key. Mm, Java provides us a map interface. It's part of the collection framework. Uh, it has many methods. You can see here. So clear. The mainly the methods are intuitively clear. I think by their names. For example, clear method removes all the elements of the map. Contains key method checks if this key consists in this map. Contains value method also checks if this value consists of the map. Also, we have a get method, get or default method. Get method returns null. Okay, get method returns. Let's see. Returns null when we call it. But if we want to just return the default value when this key is missing, then we can use get or default method. Like also put method to put the key value pair to the map, and is empty method to check if this is empty. Put if absent method, so to not put when the map contains key value pair. Replace method, size method, and values method. Also, there is the map entry class. We can see here map entry interface. We can see here this interface is sub-interface of the map, and it represents the one element, one key value pair in the map. So it stores key and value. It has no. It should just return get key, get value methods. Also, it has abstract methods like set value, equals, hash code method, and methods like this. This class is used when we just want to loop over the map. In this case, we can just create like this, loop over this when we can use the entry set method of the map, and then loop through this set using for each operator in Java, and then we can just get key and get value use getKey and getValue method to just work with each key value pair of the map. I said that the map has a different implementations. So the first one is hash table class. Hash table is a legacy class of the Java. It means that this class was introduced before the collections framework, and it is and also maintains till now. So hash table, we can see here hash table class. So if you see that t in the table is not uppercased here, so it's like hasn't renamed after creating. So it was as I said, it was created before the collections framework. It's the second version of the JDK. Okay. Hash table method is extends the dictionary class and implements map. So it provides uh, case of this hash table must implement the hash code method, and it will save this key value pair basis on the hash code of the case. So hash code is used to not to reduce resource usage when you work with big classes. For example, any string or any big classes has a uh, short hash code. So in this case, hash table will just store the not store the use this hash code to store key value pair. If this hash code is not so hash code mainly is not the same for each object, so it will check if hash codes are same or not. If hash code is same, then in this case hash table will just uh, rewrite this key value pair when you use a put method. If you use a put if absent method, then it will not rewrite this key value pair. Okay, hashmap is the same as hash table, but it's not synchronized. So also it is changed hash table, and it's most frequently used implementation of the map interface. So difference between hashmap and hashtable are listed here. So hashmap is not synchronized, and also hashmap allows null k when hashtable doesn't allow. Hashmap is introduced in JDK, second version of the JDK, when collections framework introduced it. It's faster. We also can make this hash map synchronized. It traversed by iterator, and it inherits abstract map class. But hash map and hash table doesn't store any information about the order, so we can just get when we loop through the hash map, we can get entries of this map in shuffled order. So if you want to save information about the order, you should use linked hashmap class. Linked hashmap class is the same as hashmap, but with only one difference. It maintains an order. When you put any data, it will be added to the end of the linked hashmap. So, as I said, hashmap and its subclass, it's like child classes can be we can make them synchronized with wrappers of the collections class. So wrappers is like the static methods of the collections class. So in this case, we can work finally with multi-threaded applications. Also, linked hashmap has a remove eldest entry method, which by default returns false. But if this method returns true, then when putting something, it will just call it once and then it will remove the eldest entry. So in this example, you can see how to work with this method. So we can overload this method using like anonymous classes like here. So overloading and then we can in this case it provides maximum data, and then when this size reaches maximum, it will begin to remove eldest element entry of this linked hash map. Also, Java provides enum map. Enum map is specialized map for the enum case. So it provides the same classes, same methods as map, any maps. So we can see the version. So in this case, this should extend cache should extend enum. Okay, let's continue. Also, we have properties class, which is the child class of the hash table. So it can be used to get property value based on the property key. It provides load method to load from the reader from the files and to store. We have store method, store and store to XML methods. So these files mainly this class mainly used when you work with properties of something, some applications. So in this case, compilation is not required when the information is changed. So you can just save here users names and passwords, and you can change it any time. Uh, So it has methods you see here. So it's the hash table of the string k and the string value. So it's like here. Object. Also, we have weak hash map class, which is the alternative of the hash map with a weak reference type. So when uh, you call garbage collector, this hash map will be the case of the hash map will be removed faster than because hash map has the harder reference type uses a harder reference type, so in some cases hashmap case will not remove it by the garbage collector, but weak hashmap case will be removed. Also, map has the sorted map interface. Sorted map interface is the child interface of the map. It will just it provides us some methods like here in this case. So comparator, so first key, heat map, key set, last key, and sub map, tail map. So in this case, first key, last key will just so it will store elements in some sorted order. So you can specify comparator or you can just use uh, keys which implements a comparable class, comparable interface. So it will return first key, last key. So also heat map returns a view of the portion of this map whose keys are less than 2k, less than this argument. Also submap you can use to just return the which is ranged from key to key argument, from the first argument to the second argument. Also we have tail map method, which is greater or equal. So then from k and so on. So also navigable map interface we have. So it's the child interface of the sorted map. It provides also navigation methods. So in this case we have like here we have just like uh, flower key, for example, returns the greatest key, then the argument key, also heat map and so on. So it just extends sorted map interface with navigation methods. The tree map is the mainly used sorted map and navigable maps interface. So in this case, the map is sorted according to the natural ordering of its case. It saves as a binary tree in Java. Uh, when we store something to the tree map, it will just take some time. No, it's not take a long time, but it will be slower than adding something to the hash map, for example, because it will sort and then put this key value pair to the preferred order of the map. So this lecture was over. So if you have a question, you can ask me.